Hey folks, welcome to another edition of Mr. V Teaches Math, and today we're going to be able to look at his surface area. I'm pretty sure that you've covered surface area before. I'm not entirely sure. Hoping you have. But our goal today is to be able to use formulas to calculate the surface area of three-dimensional shapes. The way that I try to understand surface area is I like to think of surface area in terms of Christmas. And what I mean by that is if I'm wrapping a present for my wife or for one of my daughters, and I have a box or some sort of package, surface area tells me exactly how much wrapping paper I need to cover the box completely. And so that's how I like to think about surface area. So our problem, well, the problem is surface area. Haha, get it? Surface area is a problem. One of the things that we do with surface area is we're going to sort of imagine a 3D shape broken down to its net. So here is our three-dimensional shape, and we're going to break it down. That's a little bit easier to see. We're going to break it down into a net. Now if you notice, I numbered all the sides, and I know I did them opposite. So here's side 1, here's side 2, here's side 3, and side 4, side 5, and side 6. We know that cubes, we know that rectangular prisms, they have 6 sides. And so for something like a cube, it's actually fairly simple to calculate the surface area. And what happens is we break it down into its net. Okay, we have these 6 sections. We have sides 1 and side 2. We have side 3 and side 4, and then side 5 and side 6. So when you break down the three-dimensional shape, this is where the sides end up. Now, what surface area wants us to do is to measure out and to calculate the area of the shapes. So, this is 5 centimeters. And also 5 centimeters. I know that area is length times width, and it's 5 centimeters times 5 centimeters, which is 25 centimeters squared. That's the area of one of these squares. Now, if I want to find the total area, so that's A to T, it's going to be 25 centimeters squared times 6, because there are 1, 2, 3, 4, 5, 6 squares. And so 25 times 6 is 150 centimeters squared. So with cubes, it's actually fairly simple to figure out the surface area because all of the faces are the same shape and have the same dimensions. Okay, so it's pretty straightforward. Now it gets a little bit more tricky. Like breaking it down to a net's a great idea. It can really help you figure out where the numbers go and how to figure stuff out. Let's try this on for size. You have this the pyramid of Khufu, who was an Egyptian ruler, was built around 2,500 BC. We're going to be calculating its surface area. And so again, we're going to be using a net to calculate the surface area. Okay? So this is a square-based pyramid, which is the way the square-based pyramids are in Egypt. And I've broken it down into a net. And so basically, this is a square down here, which means that 230 meters is the dimension all the way around. And so I can calculate that area. I know it's length times width. And I know it's going to be 230 meters times 230 meters. And that's going to equal 52,900 meters squared. Okay. I know that I have 4 triangles here. I also know that my formula is base times height divided by 2. I know that my base is 230 meters. I know that my height is 186 meters. I'll put that in brackets. And I know that I'm going to be dividing that by 2. Now I'm going to bust out my trusty calculator. And I'm going to do some multiplication on here. And so I have 230 times 186, which gives me 42,780 meters squared divided by 2 equals 21,390 meters squared. Now, I have the area of the base, I have the area of only one of the triangles. What I need to do is to take that number, so area, I'll also do lowercase t, area of the triangles, maybe I'll make it, equals 21,390 meters squared times 4, because there are 4 triangles in a square-based pyramid. So I'll multiply that number by 4, which gives me 85,560 meters squared. Then what I do is I take the area of the square and add it to the area of the triangles, which is the same thing as saying 52,900 meters squared plus 85,560 meters squared, which gives me a grand total of 138,460 meters squared. So were I to paint the pyramid of Khufu in a lovely sky blue, what I would get is I would need 138,460 meters squared worth of paint. Okay, so that's breaking it down to a net, solving the area. The last thing that we're going to try is this. We're going to calculate surface area with just a diagram here, without breaking it down into a net. You can. What I'm going to do is say, like, get out some pencil crayons and say, okay, so first thing I'm going to do is think about the front and the back, those two parts of the rectangular prism. I know it's going to be length times width. I know that it's 7 by 5. That gives me 35 meters squared. I know that there are 2 of them, so it's 35 meters squared times 2 equals 70 meters squared. Okay, so that's front and back. Next I'll do top and bottom. And so I'm just going to do that with green. Like that. So it's the next one that I look at. Top and bottom, this is 7, and then, so this is 7, and this is 9, so it's 7 by 9. So again, I know area is length times width, 7 meters times 9 meters, which is 63 meters squared. I know that there are 2 of them, and I also know that 63 times 2 is 126 meters squared. Lastly, I'm going to do side and side. So that's these ones here. Side, and then other side. Okay, so now I have all 6 sides colored in. I know it's still length times width. I know it's 9 meters by 5 meters, which is 45 meters squared. Then there are 2 of them. 45 meters squared times 2, which is 90 meters squared. Then what I have to do, I'm not done yet, I need to add the total area of each of the 6 sides. So I end up with 70 meters squared plus 126 meters squared plus 90 meters squared. So I have 70 and 126 and 90, which gives me a total of 286 meters squared. So that's the total surface area of this shape. I find coloring helps if you have pencil crayons. Hopefully you get to a point where you don't need to color, but remember to add up the total areas at the end to get your overall total of the whole shape. All right, have a great night.